Hello everyone, my name is David and today I'm gonna record this video named Black Hole's Evil Twin. Let's get started. There might be objects in the universe so brutal and strong that it could kill black holes. Gravastars. Contain bubbles filled with pure energy, with a shell made of the weirdest material impossible in nature. What do they like? What do they look like? Are they just a theoretical fever dream? Will they change our understanding of the universe forever? The birth of the most extreme objects in the universe. Very massive stars die in the most dramatic way possible, a supernova. We explained this process in detail before, but in a nutshell, it collapses their core in seconds, crushed under the extreme gravity. The star's shells rush in, bounce against the collapsing core, and explode, shining brighter than whole galaxies. Depending how massive the star was, there are two possible outcomes. Either the core compresses into a super dense neutron star, kind of breaks in reality and collapses into a singularity, with infinite dense point and no size of dimension at all. So a place where laws of the universe stop making sense, and time or space are reversed. Black hole. Gravastars are a third, even weirder option. Instead of collapsing into an infinitely dense point, the core kind of grounds down. The rock perverts into a dust by cosmic hydraulic press. Atoms and particles are crushed so hard that they transform into pure energy, a sort of mini-universe if you want. Just like our universe, the bubble only wants to expand and grow. In a fraction of a second, the bubble smashes into the collapsing star around it. The unspeakable mass of the star collapses under its own gravity, meets the tiny violence of the expanding energy bubble, like an ancient god hammering on a thingy that with unstoppable force, forging a new kind of materials that we never seen before. We know that it's physically possible, and suddenly solves. A gravitar is born. What does it look like? Cosmic soap bubbles. Just like black holes, gravastars can have any mass. A typical one would be about the size of London metro area and massive as 10 suns. This shell of gravitar is utterly dark, the coldest thing in the universe, a billion of a degree above absolute zero. If we look at the deep infra, even the cosmic microwave background glows bright in the compression. How can anything made of matter that cold? Don't all atoms juggle back and forth? The thing is, the shell is not made of atoms. It's made from entirely new, unique, and extreme matter. It doesn't have a name yet. That's why it's very limited what possible in nature. Actually, the cell is so incredibly thin that atom seems truly gigantic next to it, and yet it's spread being ultra thin because it's forged by two impossibility in extreme force. The shell is incredibly tight. So tight that if you want to stretch a whole shell just 1 meter, you need an energy of an entire supernova. What about the inside? Well, it only gets weirder. The interior gravitar is perfectly simple because it's sort of empty, completely empty. A perfect vacuum without a single atom, particle, or wave. Despite being as empty as it gets, this black hole boils with the most permanent, fundamental kind of energy in the universe. In detail to explain how any of this makes sense. The fundamental nothing at the core at all. The inside of a black hole breaks our brain a bit, because it's sort of super condense, nothingness. What does this even mean? Well, to simplify using matter and use the sense of what scientists measure and calculate. According to our current understandings of physics, particles like quarks, electrons, and photons, and so on, are not really solid objects, but a sort of wave in the ocean. In our human world, you can't have waves without water, and in the smallest world, you can't have particle waves without some kind of underlying ultimate cosmic fluid. This fluid is vacuum, what we perceive as nothingness. It's the fundamental ocean as the bottom of reality. The wave of this vacuum ocean makes that to mix up you and everything else. But when there are no waves or particles traveling through it, the fluid is still there. Any kind of fluid we know is an inherent energy. Vacuum fluid is everywhere in the universe. In your room you're in is 99.98% vacuum between the air particles bouncing around. Between your trillions of particles making yourself, there's vacuum. But there's a difference inside a gravitar. When a star collapsed and consumed itself violently, it took like a universe took a cosmic pump and compressed as much vacuum fluid as physics allow. Some kind of super dense nothingness. As said before, not even waves. The nothingness vacuum oceans of the universe has energy. But a super dense vacuum inside gravitar has almost a billion, trillions times more energy per cubic meter than vacuum outside the star. This is an unbelievable amount of energy and mass in a tiny space. Just like you have guessed, it's black hole. The intensely confined vacuum ocean can't be compressed any further. Its absolute physical limit of anything can be squeezed together without breaking physics like black holes do. The oceans will be so loved to be so tight. It will stretch out and flow back into the oceans that surround the stars. But it's trapped in the safest prisons possible, the cell, which itself is right at the edge, the physical limit of any material possible, the internal cellmate of between two limits of the universe. Let's leave the word intervals and get back to our world to feel more real. In the world, the gravastars are perfectly black, eternal objects with borderline and same amount of mass, just as so-called dark matter from outside. Gravastars look and behave exactly like black holes. They both massively curved space around them, create all kinds of effects we love black holes for, from trapping mass and light in accretion disk or slow down time as you get slower. For details, we made one or two videos or black holes before. If you fell into a gravitar, you'll be extremely dead before you even hit the surface, ripped apart and ground out by the gravitational forces. Once you touch the remains on the atoms you were once made of, you probably break down and dissolve completely, only to convert into a vacuum energy of the interior, making the star instantly a bit bigger and instantly more massive. Okay, this is fun and all, but what is the point? This is another video with science fiction, just for the sake of it, the point. Black holes are suggested more than a century ago, and are traveling to solutions to equations of gravities. For 50 years, they were considered mathematically valid and too absurd to be real. A few believe they actually exist. But scientists kept working on papers and looking at these weird things, and we saw stars being thrown by invisible titans. We saw light stretching around invisible caps of the sky. And as technology and theories improved, we even sort of took a picture of them. We have evidence and they fit our theories. Nowadays, it's more common sense that we accept for real. Black holes are extremely elegant and fascinating. They also create lots of questions, have traumatized physics for decades. Singularities really break our best understanding of physics. They seem to delete information which shouldn't be possible. Gravastars reality a new idea without any of those problems. They don't need singularity that breaks physics and delete information. They solve puzzles of black holes. But they too also create new problems, like the exotic matter for the incredibly cold and tight cell. Surprisingly, nothingness makes a supermassive empty core. Just like black holes, they do work on paper and fit what we see in the sky. So are they real? And will we ever know? Actually, there's a way to find out. Black holes have an event horizon, while gravastars have a physical shell made of matter, which means they behave very differently, and when smashed into each other, a collision of two objects as massive they are create huge amounts of gravitational space, ripples in the space-time that travels at the speed of light. You can think of them as the music of cosmic caverns. The collision of two black holes shoots down like a mass drum. Deep down the drop stops quickly. But two colliding gravastars colliding should be a cow, leaving several echoes behind. Scientists are listening for these echoes in the music of cosmos. Unfortunately, black holes and gravastars are surrounded by such strong gravity it swamps the most of the music. Like trying to sell two instrument through a thick wall of concrete. You need a very sharp technologies for that. While we made an incredible process in the last few years, we're not quite there yet. So here is the place we end the story. Gravastars have the biggest potential answers to some of the biggest problems in the universe. Maybe there's just an idea for a discard file. But this is why we do science. To learn everything that is different by the way we thought it is, until one day we truly understand the nature of reality.